Acyl chlorides are useful reagents in synthesis. They react with aromatic compounds and also with um, alcohols. Reacts with benzene, CH3, CH2, ClCl. Acyl chloride reacts with benzene, presence of AlCl3 in electrophilic substitution reaction. Given the equation for the reaction of this with AlCl3. So it's going to be AlCl3 plus CH3CH2ClCl arrow CH3CH2C double bond O, carbon positive, and then the AlCl4 minus plus AlCl4 minus, and that's a carbocation. So AlCl3 plus CH3CH2ClCl, CH3CH2 C double bond O, carbon positive, plus AlCl4 minus. And then our mechanism for this electrophile with benzene. So benzene. So we're going to have benzene and we've got CH3CH2. We've got CH2CH3C CH3CH2Cl. So it's going to be CO CH2CH3 carbon positive. Just flip that around, and it's going to go from the ring of delocalized electrons to the carbon, and now you form the original thing, but now you've got this horseshoe ring, positive charge, and now maybe the horseshoe ring. Yeah, the horseshoe ring probably should be here, and now it's bonded to a hydrogen and a CH2CH3, CH2CH3, and then from the middle of this hydrogen to the positive charge, and now what happens is you've got this kind of structure. Really bad diagram. 1, 2, 3, 4. No, that's not even 1, 2, 1, 2, 3, 4, 5, 6. Now I've got it. And what happens is these double bonds are alternating, 3 alternating double bonds, and you've got CO, CH2, CH3, positive, and it goes from here to there, and now, actually no, we're done. We are done. I don't know why I even did this. That's it. That's all we're doing. From the ring of delocalization to the carbon, which is positive, and then partial horseshoe ring, positive charge, hydrogen COCH2CH3 from the middle of the hydrogen bond to the positive charge, or at least close to it. Because on the mark scheme said all this, so we don't need this. And that's for 4 marks. And then 7.2, 7.3. 7.2 says, give the IUPAC name of this alcohol, give the reagent needed for this reaction, and name the mechanism. So the IUPAC name of the alcohol, well, you've got an alcohol on, what is this? Methane, ethane, propane. So it's propan. You've got an alcohol on the first carbon, and you've got a phenyl group. So it's going to be 1 phenyl 1 phenyl propan 1O with a dash, propan dash 1O. 1 phenyl, you've got phenyl, and you've also got an alcohol, and it's propan because 3 carbons. The reagent for this reaction, well, the organic compound product in question 7.1 can be converted into this alcohol. Organic product in question 7.1. It's going to be, what's it called, nucleophilic addition, because all we're doing, as you can see, is we are adding we're just adding something on, so it's going to be nuclear. All we're doing actually, we've got a hydrogen, we've got COCH2 CO3. Yeah, all we're doing is we're adding a hydrogen, I think, and the reagent LiAlH4. But actually for this one is probably NaBH4 or LiAlH4. Doesn't really matter which one you put in. NaBH4 / LiAlH4. Alcohol shown in question 7.2 reacts with ethanol chloride to form an ester. Alcohol reacts with ethanol chloride to form an ester. It's going to be nucleophilic addition elimination. Nucleophilic. You just need to be so confident with your mechanisms. Review them so many times that you just see a reaction between something and something, you can already name it, and you can already, imagine what it's going to look like, where the curly arrows are going to go, etc, etc. I'm not at that point yet. Maybe you guys are, but I'm not, definitely not. What would be observed was going to be misty fumes, and draw the structure of this ester. Well, we've got we have got, it's going to be, well, we're going to have an ester, so it's going to be CH2CH3H. Okay, it's going to be C phenyl group, attached to it hydrogen, CH2CH3 O, C double bond O, CH3. What I would do for this question is I'll leave it to last, just this specific part, and then once I'm done with all the questions, and I've got like 5 minutes of extra time, then I'll go through the actual mechanism, and then I'll see the product formed, because I feel like that's the best way to do it. But obviously that will take a lot of time, like maybe 2-3 minutes, so that's why I leave it to last, just for 1 mark. Yeah, so CH3, C double bond O, C, CH2, CH3, H, and phenyl group. And that is the end of question 7.